A uniform electric field and a uniform magnetic field are acting along the same direction in a certain region. If an electron is projected in the region, okay, such that its velocity is pointed along the direction of the fields, then the electron, okay, if electron is projected such that velocity is pointed along the direction of the fields, okay. Now velocity is projected along the direction of the fields, right? What I know is that, okay, direction of acceleration will be along the direction of the electric field, and a bar equal to v bar by t, right? a bar a bar by t. Here they are saying that velocity is projected along the direction of the fields. Then they are asking what is the direction of electron. This charge of electron will be minus e. So I will write v bar equal to minus e by m times e bar, okay, with respect to electric field. And with respect to magnetic field, we can say that velocity is perpendicular to magnetic field. V bar is perpendicular to magnetic field. Okay. Okay. Now, whenever the electron is projected in a region such that velocity is pointed along the direction of field. If suppose if V bar is along the direction of magnetic field, then I can say theta is 0. There will be no motion now. So magnetic force is 0. So V bar it is negative now. V bar equal to minus E into E by M into T times E bar. So velocity decreases now. Okay na? So option will be
B, sir.
Option B.
Yes, sir.
Next.
8th question, sir.
1 minute. Next question. 8th one. A very long straight wire carries a current I at the instant when a charge plus Q at point P has velocity. Okay, Vy as shown. The force on the charge is, firstly, we are having a straight conductor like this. Current is flowing. Right? We are having a point P. Here it is point P. Here we are having a charge plus Q. Is moving. Okay?
Yes, sir.
They are asking to find the force on the charge P
Yes, sir.
or charge Q. What will be the direction of the force? Right?
Yes, sir.
Okay, fine. Firstly, here we are having that. Here we are having, this is the, suppose this is conductor 1. Here it is 2. Right?
Yes, sir.
Okay, fine. Let us consider this distance as D. As D. Then I can say that it is F is equal to we are having the like this now. This is x-axis
Yes, sir.
and this is y-axis. Okay. Okay,
Yes,
fine.
sir.
Okay, fine. Now, force acting on charge q, right?
Yes, sir.
This charge q is moving with a velocity v naught or
Yes, sir.
vy.
B.
That one. Hmm? Vy. So, force I can write as F equal to mu naught by 4 pi
A.
2 I1 I2 by d. I1 means
Yes,
it is
sir.
I. I2 with respect to this charge, right?
Yes, sir.
Correspondingly, we are having a current. Suppose let us consider I2. Okay, na?
Yes, sir.
Okay, fine. Now we are having that motion of the particle of the charge q is having a velocity parallel to x-axis.
Yes, sir.
Okay, na? Right?
Yes, sir. Yes, sir.
Okay, fine. Whenever it is motion is parallel to x-axis, according to the right hand thumb rule, we'll have the rotation will be inwards, magnetic
Yes,
field will
sir.
be, direction of magnetic field will be inwards.
The field will be inverse, yes, sir.
So, by applying the Fleming's right hand rule, direction of magnetic field will be P naught times minus K cap.
Okay. Yes, sir.
Okay. By applying the Fleming's right hand rule, we can find the direction of force. That
Yes,
means
sir.
Q times V bar cross B bar.
Newton plus B bar.
V bar means V naught I cap cross
I cap
B naught minus
plus
K cap.
B naught minus K cap. Yes, sir.
So F bar equal to B naught Q V naught with minus sign outside I cap cross K cap. So
Minus
if
B.
you take inside this negative sign, B naught Q V naught K cap cross I cap.
I cap. Yes, sir.
K cap cross I cap means J cap now along y
J
axis.
cap. Yes, sir.
So
Yes,
in the
sir.
option it is along OY.
Along OY. Yes, sir.
That is the force acting on the charged particle Q.
Yes, sir.
Right? Right
Yes,
down.
sir.
Okay, na?
1 minute, sir.
Now,
Yes, sir.
completed.
Yes, sir.
Next,
Uh, 17th question, sir.
17.
Yes, sir.
A particle of mass m and charge q, kinetic energy T, enters in a transverse uniform magnetic field of induction B. After 3 seconds, kinetic energy of the particle will be, right? Suppose,
Yes, sir.
let us consider I am having a particle having a mass m, charge q, and kinetic energy is T. Enters in a transverse. Transverse means perpendicular direction in a magnetic field
Okay,
of
sir.
induction B. Okay. we are having the magnetic field
Okay.
like this, right?
Yes, sir.
Now a particle is enters like this.
Yes, sir.
Okay. Now
Yes.
they are asking after 3 seconds.
Mm.
After 3 seconds, what is the kinetic energy of the particle? Right?
Yes, sir.
Okay, na?
Yes, sir.
Fine. Whenever a particle enters here,
Mm.
okay, the total energy will be equal to kinetic energy.
Yes,
Don't
sir.
have any potential energy, na?
Yes, sir.
Right?
Mm.
We don't have any other energy.
Yes, sir. We don't.
So after 3 seconds, after at any time, total energy must be
Mm.
conserved.
Concept. Yes, sir.
So total energy
Mm.
must be conserved. So after 3 seconds also, kinetic
Oh,
energy will be
kinetic
equal
energy
to
will be T.
will be T.
Yes, sir.
After 3 seconds also, kinetic energy equal to T.
Yes, sir.
So option
Option A.
option A, right?
Mm. Mm. Finished, sir.
Hmm?
Completed, sir.
Completed. Next one,
21st and 22nd.
21st
Yes, sir.
is a positively charged particle moving due east enters in a region of uniform magnetic field directed vertically upwards.
Yes, sir.
Okay, like this,
Yes,
we
sir.
are having the magnetic field.
Yes, sir.
Okay, fine. This is magnetic field. A positively charged particle moving due east. Okay, enters a region of uniform magnetic field directed upwards. Then this particle
Mm.
will be. Okay,
Mm.
we need to find the trajectory, right?
Mm.
We need to
Yes.
find the what is the trajectory of this path.
Mm.
Okay, fine. I know that it is moving with a velocity v. V is
Mm.
perpendicular, right?
Yes, sir. Yes, sir.
So v is perpendicular means then we can say that the radius of circular path is mv by bq,
Yes,
r
sir.
equal to mv by bq,
Yes,
right?
yes, sir.
Okay. R equal to mv by bq.
Mm.
Mm,
Mm.
At any point,
Yes,
speed
sir.
is same, moving with
Mm.
uniform speed. Na? So it will be option B,
Yes, sir.
move in a circular path with uniform speed.
Okay. Oh,
Okay. See the key,
okay, sir.
21B.
Okay. Yes, sir. Option B.
Moves with uniform speed. Na?
Yes, sir.
After 21,
22, sir.
22. A 10 electron volt electron is circulating in a plane at right angles to a uniform magnetic field at magnetic
Mm.
induction. Okay, given that magnetic
Yes.
induction is 10 power minus 4 Tesla or Weber per meter square.
Mm.
Energy it
Mm.
is 10 electron volt. 10 electron volt. They are asking to find the orbital radius, right?
Yes, sir.
Okay, fine. We know that kinetic energy equal to B square, Q square, R square by 2m.
By 2m. Yes, sir.
And they gave that it is particle is electron.
Yes,
So
sir.
R square equal to kinetic energy, I'll write as K. So R equal to under root 2mk by Q,
Yes, sir.
right?
Yes, sir.
Okay, R equal to mass of electron, that is, what is the value?
9.1 into 10 power
9.1 into 10 power minus 31. Kinetic
31. Yes,
energy
sir.
is 10 electron volt now. 10
Yes,
into
sir.
1.6 into 10 power minus 19 divided by BQ, 10 power minus 4. Q means 1.6 into 10 power minus 19,
10 power.
right? So
Yes,
R
sir.
equal to,
Yes, sir.
sorry, R equal to under root of 18.2. 10 into 1.6 means I'll write as 16. Okay.
Yes, sir.
1.6 into 10 power minus 23. This one I will write as 4 into under root 18.2 10 power minus 25
Yes, sir.
by 1.6 into 10 power minus 23.
Yes, sir.
So 4 by 1.6 means 40 by 16.
40 by 60. Yes, sir.
So it will be 5 by 2
5 by 2. Yes, sir.
into under root 18.2 10 power minus 2
10
meter.
power minus 2 meter.
Under root 18 means it is like 4.2
Yes, sir.
right now. 5 into
Yes,
4.2
sir.
means approximately in between 10
Maybe
and 11
20.
now.
Yes, sir.
11 centimeter
Yes, sir.
right now.
Yes, sir. Option A.
Right. Under root of 18.2, it is 4.266.
Yes, sir.
Okay.
Yes, sir.
Approximately here we are getting 10.66 centimeter. Approximately 11 centimeter.
Yes, sir.
Okay, na?
Yes, sir.
Right on.
Completed, sir.
Completed. Next one.
Yes, sir. 25th, sir.
25. 1 minute. An alternating electric field of frequency nu is applied across the Ds of a cyclotron that is being used to accelerate. The operating magnetic field used in cyclotron and the kinetic energy of proton beam produced by it are. Here in the cyclotron, we are having the two Ds like this. Okay.
Yes, sir.
Now in between this one, we will have the like this layers.
Yes, sir.
Okay, na?
Yes, sir.
Now, suppose that let us consider an alternating electric field is applied. This is my radius of each d,
Yes, sir.
and a proton is accelerating. That means this proton is accelerating in a circular path now.
Yes, sir.
So I can write mv square by r equal to pqv. So
Yes, sir.
mv equal to bqr. Okay. Kinetic
Yes,
energy
sir.
equal to, I know that half mv square,
Yes, sir.
that is m by 2 into v square means b square q square
B
r
is
square by
B
m
square R
square.
square by M
So
square.
kinetic
Yes,
energy
sir.
equal to b square q square r square by 2m.
2. Yes, sir.
Okay. Since it is moving in a circular path, I can write v equal to r omega.
Yes, sir.
Okay. M into,
Yes, sir.
I'll substitute here. Okay. In this equation,
Yes, sir.
m into r omega equal to bqr.
Yes, sir.
So omega equal to bq by m.
Yes, sir.
Okay.
Yes, sir.
Omega equal to bq by m. Okay. Now, so this I will write
Yes,
as
sir.
m by 2 b square q square by m square. I can write as omega square
Yes, sir.
r square. This omega means 2 pi n or 2 pi nu.
Yes, sir.
2 pi
Yes,
nu
sir.
whole square into r square. So it is
Yes, sir.
2 pi square nu
R
square m
square.
r square. See the
Square.
option?
Yes, sir.
2 pi square m nu square r square.
R square.
Okay.
Yes, sir.
Fine. And then we need to find the magnetic field. We need to find the
Yes, sir.
magnetic field.
Magnetic. Yes, sir.
Magnetic field we can write as BQR equal to MV.
Yes, sir.
Okay. Or we can write as omega
Yes, sir.
equal to 2 pi m. Na? B equal to
Yes, sir.
M omega by
2
Q.
pi. Yes, sir.
That is
Option C.
M by Q into 2 pi nu.
Yes, sir.
Right now. Instead of Q,
Yes,
they
sir.
kept as E. E.
Mm.
Instead of Q, they kept it as E.
Yes, sir.
Okay, na?
Yes, sir.
Next,
Option C. 26.
20,
Question number 26, sir.
26. This one over.
Yes, sir. Yes, sir.
Question number 26 it is, a particle having a mass 10 power minus 2 kg carries a charge. Okay. Q,
Yes, sir.
Q is equal to 5 into 10 power minus 8.
Yes, sir.
5 times 10 power minus 8 coulomb. The particle is given
Yes, sir.
horizontal velocity. Suppose I will keep as Vx. 10 power 5 meter per second in presence of electric
Yes,
field
sir.
and magnetic field to keep the particle moving in horizontal direction.
Yes, sir.
it is necessary that B should be perpendicular to the direction of velocity and E should be along the direction of velocity. Both B and E should be along the direction of velocity. Both B and E are mutual direction perpendicular to velocity. Okay. B should be along the
Okay, sir.
direction of velocity and E should be perpendicular. So E should be along the direction of velocity. That is one is confirmed.
Yes, sir.
Okay. So
Yes, sir.
along horizontal direction only it should be there means magnetic field also in the same direction. Okay.
Along the direction of velocity, yes, sir.
Otherwise, velocity should be in this direction means F bar equal to Q into V bar cross B bar now.
Yes, sir.
So it is I cap. This one it is I cap.
Yes,
Okay.
yes, sir. Yes,
This
sir.
B bar, suppose if it is inverse, that is in minus K cap.
Yes, sir.
That is force is along J cap. Na?
Yes, sir.
B bar should be perpendicular to the direction of velocity
To
and
the
E
direction of
bar be
velocity.
along the direction of
Along the
velocity.
direction of velocity. Yes, sir.
Okay.
Yes, sir.
So it must be first one it is B bar is B bar is perpendicular is not both B bar and E bar should be along the direction of velocity. If it is along the direction and statement 2 and 3 are correct. Say both
Both.
B bar and E bar should be along the direction of velocity.
Direction of velocity. Yes, sir.
Should be along the direction.
Yes, sir.
Along the direction of velocity. Number one. And next one, if B bar and E bar both are perpendicular to velocity,
Yes,
then
sir.
also particle will move in x-axis, na?
Yes, sir.
Right? In electromagnetic waves,
Yes,
we'll get now E bar equal to V bar cross B bar.
Yes, sir.
Okay.
Yes, sir.
E bar equal to V bar cross D
V
bar.
bar.
So V
Yes,
bar
sir.
must be perpendicular to both electric field and magnetic field. Na?
Yes, sir.
Okay. That is 2 and 3 are correct. So it is option C.
Yes, sir.
Is the answer? C. What they give?
Option C, sir.
C only, na?
Option C, sir. Yes, sir.
Next.
1 minute, sir. And next, 27th, sir.
27.
Yes, sir.
A beam of electron passes undeflected through mutually perpendicular electric and magnetic fields. Electric field and magnetic field are mutually perpendicular.
Mutually perpendicular.
If electric field is switched off and the same magnetic field is maintained, the electrons move in. Okay, the electrons will move in. Okay, firstly, a beam of electron passes undeflected through mutually perpendicular. Let us consider this is the direction of electric field and this is the direction of magnetic field.
Magnetic
Right?
field.
Okay,
Yes, sir.
fine. Now they are
Yes,
asking
sir.
that it is what will be the in which direction the electrons will move, right?
Yes, sir.
So
When
we know
electric
that E bar equal to V bar cross B bar.
C bar. Yes, sir.
So V bar is perpendicular to both E bar and B
C
bar.
bar
Can I
and
say
V bar. Yes, sir. Yes, sir.
right now? Now what they are saying
Yes,
that
sir.
electric field is switch off.
Yes. Yes, sir.
We don't have electric field. We are
Field.
having the magnetic field only.
Magnetic field. Yes, sir.
Okay.
Uh,
Magnetic field is developed when the
uh,
charged particle moves in a closed path now.
yes, sir.
Okay. When the magnetic
Yes, sir.
field moves in a closed path,
Uh,
right? That is in
uh,
the circular path.
yes, sir.
In the given option, you can see
Mm.
they give circular orbit. Parabolic
Circular
pathway
orbit.
either like this or like this now,
Mm.
which is not closed.
Yes, sir.
Parabolic
Yes,
path is
sir.
wrong. Straight line,
Yes, sir.
it is also not closed.
Yes,
Wrong.
yes,
Elliptical
sir.
means like this now.
Yes, sir.
Okay. Here,
Yes, sir.
electric field is perpendicular to magnetic field.
Yes, sir.
Initially, we consider the charged particle is moving in a circular path of radius r now. Shape of the particle or trajectory of the particle,
Mm.
it is a circle only.
Mm-mm. Yes, sir.
That is option A, circular orbit.
Yes, sir. Yes, sir.
Mm, right now,
Completed, sir.
completed. Mm.
Yes, sir.
Next one.
20, 28, sir.
Up to here you did, no?
Yes, sir.
Okay, fine. 28. In a mass spectrometer
Mm.
used for measuring the masses of ions, ions are initially
Mm.
accelerated by electric potential
Oh,
and then made
mm.
to describe semicircular path of radius r using a magnetic field. If V and B are kept constant, okay, that is electric potential
Mm.
and magnetic field are
Magnetic field.
kept constant.
Capricorn.
The ratio
Uh,
charge by mass Q by M is proportional to, they are asking, right?
uh, yes, sir.
Okay, fine.
Yes, sir.
Okay.
Uh,
Now, with respect to the, whenever we apply an potential difference,
mm.
we'll have an kinetic energy, can I say,
Yes, sir.
right now?
Yes, sir.
Okay. Since potential is
Uh,
constant, I can write as
mm.
mv square by 2 times v. Okay. 2 times v.
Yes, sir.
Now, with respect to the magnetic field,
Mm.
with respect to magnetic force, it is
Man.
dqv.
DQV.
Okay. So kinetic
Yes,
energy
sir.
equal to b square q square r square
Square R
by
square
2m.
by 2M. Yes, sir.
Okay, na? So,
Yes, sir.
it is 2mk is equal to b square q square r square.
Mm.
Radius it is, they gave it as r now. Okay,
Yes, sir.
it is 2m, this is r square.
Yes, sir.
So m is equal to b square q square r square by
Yes,
2k.
sir.
Okay, na?
Yes, sir.
This
Yes, sir.
one I'll write it as q equal to kinetic energy by voltage potential.
Yes,
So
sir.
q by m equal to k by v divided by b square q square r square by 2k.
By 2K. Yes, sir.
That is 2k square by
Yes.
b square q square r square into v. They gave potential
And
and magnetic field are constants now.
yes, sir.
So q by m is proportional to 1 by r square.
1 by R square. Yes, sir.
Right now.
Yes, sir.
So 1 by r square means option A.
Yes, sir.
Right now.
Completed, sir.
Complete. Next question 29.
29 solved, sir. Till 32 solved, sir.
Till 32. 30, 31, 32 got a
Yes, sir.
33 we need to do.
No,
Right?
sir. Yes, sir. Yes, sir.
33. A straight conductor carrying current I splits into two parts shown in the diagram. The radius of the circular loop is R. Total magnetic field at the center P. Okay, fine. We are having a circular loop.